Hello, welcome back to the video lecture series for Introduction to the Art of Programming using Scala. And we're still in the chapter on loops. We've talked about our while loops, our for loops, and we've given lots of options for the for loops. We even looked at an example with them. I'm going to take a little detour here, go off on a tangent, talk about multi-dimensional arrays. We'll see they kind of fit in nicely with this. And the idea of a multi-dimensional array is that it's an array of arrays. And these don't have to be arrays. You can make multi-dimensional lists as well, and you could mix and match depending upon what you want to do. It's common to use arrays simply because they have the fast direct indexing, so that you can very easily get to a particular location in them. Now, to understand these things, how would we make a multi-dimensional array? So when you create an array like this, we get a new array, and that it says that it has a particular type which matches the things that can go inside of there. This type parameter can be any type, and it turns out that array of int is a type. So it's possible to have an array of arrays of ints, or an array of doubles, or an array of arrays of ints, or an array of lists of arrays of ints, or an array of ints. Whatever you want. You can combine them however you want because each of those things is a valid type in and of itself. How would we create one of these things? Well, the simple way to do this is, of course, to make an array and have the things inside of it be arrays. Okay, so that makes, note the type, an array of ints, and so this outer array holds inside of it arrays of ints, and each of these has inside of it those values. How do we get things out of here? Well, so if I just put a single index, so if I get out sub-0 on this, that gives me the first element, which is itself an array. So when you index in, basically you're peeling off one of the arrays. How would I get to the actual value? So let's say I wanted to get to the value 2. Well, for that I need to index into that array. And so I can do that simply by putting another set of parentheses and the index that I want to pull out from there. Okay, so you can index into your multidimensional arrays this way by giving successive indices. This way of making things, once again, works reasonably well, assuming that your arrays are very small. But a lot of times, especially once you go beyond 2 dimensions, if you go up to 3 dimensions, it's almost impossible to have a small 3-dimensional array. So how else could we create these? Well, you might remember that we did create large arrays with new. So I could make a new array of int. Now if I just pass this a single argument, what this does, actually let's go with 10 so it prints out nicely, doesn't fill the screen. Sorry, had an extra. Okay. Note that this gives me an array that's full of a whole bunch of nulls. Well, that's because the array of int, the default value for an array of int is null. And we could go through and set those. So for example, res4 sub 0 equals a new array of int that has, say, 15 elements in it. And then if I look at res4 again, I can see, okay, well, the first one's been filled in. I can also pass 2 arguments here. So if I wanted to make a complete rectangular array, I could do this. Now, you'll note there is a deprecation warning. This is not the ideal way to do this. And in fact, as we talked about before, this whole calling new to make arrays like this is generally not what you want to do. There are better ways of doing this in Scala. And one of those, as we've seen, is using fill. So if I use array.fill, and I wanted to make just an array that had 10 values in it, I could do that. But I want to make a 2-dimensional array. Well, turns out that really isn't hard. We just pass fill 2 arguments in the first argument list, and those are the lengths in the 2 dimensions. So this makes an array of ints where the first level array has 10 elements in it. So this will say array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. And each one of these, if you were to count it out, has 15 zeros inside of it. Okay, so this has created a 10 by 15 array. You can picture this as being like a table or a matrix, and when you picture a spreadsheet, that's basically what you get with a two-dimensional sequence. Okay, so array.fill will work. In addition to array.fill, you can use tabulate, and so when you use tabulate, we need to have functions that take 2 arguments. And so here we get one where, okay, so the entire first set is zeros because 0 times anything is 0. The next one is multiples of 1s. The next one is multiples of 2, 3, 4, etc. So you can do the same thing that you can do with fill, with tabulate. If I provide a third argument in there, I get a 3-dimensional array, and we can make whatever size we want. We could do interesting things with this. For example, in the case of tabulate, it wouldn't be too hard, because I have an x and a y value in here, to, for example, fill a big array with values of some function that we might find interesting, like the cosine. And so since these are going from 0 to 100, I could do something like math.cosine of, actually let's go ahead and let's put in some curly braces, because otherwise this won't be quite so nice. Let's do val. So first I want to stretch things. So I'm going to say that x equals I minus 50. So this way, instead of being from 0 to 99, it's from negative 50 to 49. And I want to take that and divide by 50.0. Okay. So that's going to stretch the x value now between negative 1 and 1. And I'm going to do the same thing. I'm going to create a y that does the same. J minus 50 divided by 50.0. And why would I do this? Well, because cosine isn't nicely behaved between 0 and 100. I would like to get something closer to the value that to values that are interesting and useful to me. And the 0 to 1 gives me something reasonably nice. So I could take a math.cosine of the x times x plus y times y, and let's go ahead and let's multiply this whole thing times 10. Close that off, and close off the parentheses for the tabulate, and there we go. And so if you had this printed out, if we could plot it, and we'll learn later how we can do graphics, you would get an interesting kind of rippling 3D function, except we'd plot it in 2D, so you just see the color coding on it. What are some other things that we could do with this that are interesting? Well, I mentioned earlier that two-dimensional arrays are good at representing or matrices. Okay, so we could write a function called like matrix add, which takes one matrix, an array of doubles, and then another matrix, which is an array of, actually why don't I go ahead, let's copy this, and then quit out vi matrix.scala. Let's put this inside of a file. Array of double, and I want this to return to me a new array of double equals. So how does one go about doing this? Well, we need to look up values in each of the two arrays, and of course they have to be the same size. If they're not the same size, the function as we're going to write it right now will crash, or actually technically, yeah, it will not behave properly. So how can I make this happen? One way of doing this would be to go ahead and create a new array. So I could say val, I like to use the variable name ret for the variable that I'm going to wind up returning in the end. How about we make a new array and I'm going to use, so one way, let's do array.fill of m1.length, comma, m1 sub 0, that's an L, m1 sub 0 dot length, and then I'm going to fill it with zeros. At the end I have to return that value. And what is each element inside of it going to look like? Well, I have to run through all of those. Maybe one way to do that would be with a for loop, for I in 0 until ret.length, and I'll use two generators here, j in 0 until ret sub 0 dot length, ret sub I sub j equals m1 sub I sub j plus m2 sub I sub j. So that's one way that we could do this. What are some others? Well, how about, let's go ahead and comment these out. This is building an array and then going through and filling it. What if we were to try to fill it as we build it? Well, then we could do something like array.tabulate. In fact, this is probably the ideal. m1.length, comma, m1 sub 0 dot length. And the value that I want to put inside of here is m1. Let's go with, so first I need I comma j. I have to write this as a function, and I'll put a body here. So m1 sub I sub j plus m2 sub I sub j. There we go. That's an alternate version that's shorter than the original. Now, of course, we're in the chapter on loops, so what if we want to do this with loops? Well, I did use a for loop up here. What if I wanted to make it so the for loop is actually constructing the arrays? Well, then I could have it so that here I am going to run through all the values inside of the matrix. So let's say the row is going to be, let's see, we're actually forcing a requirement of returning array, sure. So the row is, how do I call R1, R2, inside of M1 zip M2. We'll go with the dot notation. I don't have to here, but we'll do that. Yield. Now note that in this case I am not using a second generator inside the same for loop, because if I did that I would just get one long array instead of an array of arrays. And inside of here what I want to do is I want to run through each of the elements of R1 and R2. So let's call it x1, x2 is the values in R1 zip R2, and what I want to yield is simply x1 plus x2. Okay. So this would be yet another way to do this. This one uses yields on a for loop to do the addition. You should play with multiplication. Multiplication is a bit harder because you have to run through things, but I'll leave that as an exercise for the viewer. And we'll come back in a bit, and in the next video I'm actually going to show you something that's a little bit different, and it's kind of an advanced topic, and that's parallel loops. So that should be exciting.